Have you ever stopped to wonder how the computer, an everyday tool that we now take for granted, came into existence? This question takes us on a journey back through time to the earliest forms of computation. It all begins with the humble abacus. Dating back to ancient times, the abacus was an early tool used for calculations. Its simple design of beads sliding on rods allowed users to perform arithmetic tasks more efficiently than with pen and paper. Fast forward to the 17th century and we encounter the mechanical calculator. This ingenious device was the brainchild of Blaise Pascal. It was known as the Pascaline and was capable of addition and subtraction. Pascal's creation marked a significant leap forward in computing, proving that machines could be used to perform complex calculations. The 19th century brought about even more advancements. Enter Charles Babbage, an English mathematician and mechanical engineer often referred to as the father of the computer. He designed the difference engine, a mechanical calculator designed to compute polynomial functions. Yet his most ambitious project was the analytical engine. This machine was intended to carry out any mathematical operation using a combination of punch cards to input data and instructions. Although it was never built during his lifetime, Babbage's analytical engine laid the foundation for the modern computer. While Babbage might be the father of computing, Ada Lovelace is certainly its mother. She worked closely with Babbage on the analytical engine. Lovelace was the first to recognize that this machine could do more than just crunch numbers. She wrote what is now considered the first algorithm intended to be processed by a machine, effectively making her the world's first programmer. So, the seeds for the digital revolution were sown centuries ago, but it took us a while to get to the machines we recognize as computers today. If we fast forward to the 20th century, we arrive at the birth of modern computing. This journey begins with the development of the first electromechanical computers in the 1930s and 1940s, a period of rapid technological evolution. One of the pioneers during this time was a German engineer named Konrad Zuse. He built the Z3, the world's first fully automated programmable digital computer. It was a marvel of its time, using more than 2,000 relays to perform calculations. However, the Z3 was not a general-purpose computer, as it was specifically designed for solving complex mathematical problems. On the other side of the Atlantic, at Harvard University, a team led by Howard Aiken developed the Harvard Mark I. This machine was a major leap forward in computing technology. It was an electromechanical computer that used rotating shafts and gears to perform calculations. A far cry from the sleek, silent devices we're used to today. But the real game-changer came in the mid-1940s with the development of the ENIAC, or the Electronic Numerical Integrator and Computer. This was the first general-purpose electronic computer. It was massive, filling a room the size of a small house and using 18,000 vacuum tubes. Yet, despite its size, it could perform thousands of calculations per second, a speed unheard of at the time. Not long after, the UNIVAC, or the Universal Automatic Computer, was developed. This was the first computer to be commercially available, marking the start of the computer industry as we know it. It was able to store and process large amounts of data, making it highly desirable for businesses and government institutions. The 20th century was a time of remarkable innovation and progress in computing. From the electromechanical behemoths of the 1930s and 1940s to the electronic general-purpose computers developed later, each step brought us closer to the digital age we live in today. With these machines, we were finally entering an era where computers started to resemble what we use today. The 1970s and 1980s brought about a revolution that made computers accessible to the masses. It was an era of unprecedented innovation, one that saw the birth of the microprocessor. This tiny yet powerful component was a game-changer, providing the processing power of a room-sized computer in a device small enough to fit in the palm of your hand. It was this innovation that paved the way for the development of personal computers. In the mid-1970s, the Altair 8800 emerged as the first successful personal computer. This machine, a marvel of its time, was a kit computer, meant to be assembled by the user. It was rudimentary by today's standards, but it sparked a revolution. It inspired a generation of hobbyists and tech enthusiasts, including a young Bill Gates and Paul Allen, who wrote a version of the programming language BASIC for it. Shortly after, in the late 1970s, the Apple II entered the scene. Developed by Steve Jobs and Steve Wozniak, this computer was a significant leap forward. It came equipped with a color display, a keyboard, and the ability to run various software applications. The Apple II was not just a product but a promise of what personal computing could be. And then, in the early 1980s, came the IBM PC. With its powerful processing capabilities and high-quality build, it quickly became a standard in business computing. It also cemented the dominance of Microsoft, whose MS-DOS operating system was chosen by IBM for their PC. But the revolution didn't stop at hardware. The era also saw the development of user-friendly graphical interfaces, a departure from the text-based commands that were common at the time. These interfaces, like the one introduced by the Apple Macintosh, made computers more accessible and intuitive to use. And let's not forget the introduction of the internet. This digital frontier transformed personal computers from standalone devices into portals to a global network, forever changing how we communicate, work, and play. This era truly democratized computing, turning it from a specialized tool into a household staple. The turn of the millennium brought with it two major shifts in computing: mobility and the cloud. As the 20th century gave way to the 21st, the digital landscape began to change in dramatic and exciting ways. The first of these changes was the evolution of laptops. The bulky, cumbersome machines of the 90s began to slim down, becoming lighter, faster, and more portable. Companies like Apple and Dell led the charge, rolling out sleek models that were as stylish as they were functional. But this was just the beginning. Soon, the world of computing became even smaller with the rise of smartphones and tablets. These devices, no larger than a book, packed the power of a full-sized computer into a handheld gadget. With the introduction of Apple's iPhone in 2007, the smartphone quickly became a must-have item, forever changing the way we interact with technology. At the same time, the growth of the internet was reshaping the digital world. The World Wide Web, once a novelty, had become a necessity. It was no longer enough to simply have a computer. Now that computer needed to be connected. This connectivity gave rise to cloud computing, a revolutionary concept that made data and applications accessible from anywhere. No longer were we tied to physical storage devices. Documents, photos, even entire software applications could be stored in the cloud and accessed from any device at any time, in any place. Companies like Amazon, Google, and Microsoft were at the forefront of this shift, offering cloud-based services that transformed the way we work, play, and communicate. These changes have made computers an integral part of our daily lives, always at our fingertips. We can work from a coffee shop in New York, video chat with a friend in London, or stream a movie in Tokyo, all thanks to the power of mobile and cloud computing. It's a digital world, and we're just living in it. So, where are we headed next in the evolution of computers? The future of computing is a fascinating topic, filled with equal parts of certainty and speculation. One of the most exciting developments we're seeing today is the rise of quantum computing. Unlike traditional computers that use bits, quantum computers use quantum bits or qubits. This allows them to process information in ways we've never seen before, opening up new possibilities for complex calculations and data encryption. While we're still in the early days of this technology, its potential is immense. But the future of computing isn't just about more powerful processors, it's also about smarter software. Artificial intelligence, or AI, is becoming increasingly sophisticated, capable of tasks that were once thought to be exclusively human domain. From self-driving cars to virtual assistants that can understand and respond to natural language, AI is set to radically transform our relationship with technology. The implications are vast, affecting everything from job markets to privacy concerns. And then there's the realm of virtual reality, or VR. This technology promises to transport us to entirely new worlds, all from the comfort of our living rooms. Whether it's for gaming, social interaction, or even remote work, VR could fundamentally change how we interact with digital spaces. And as the technology improves, these virtual experiences will become even more immersive and realistic. But while these technologies are exciting, they also bring new challenges. How do we ensure the security of quantum communications? How do we navigate the ethical implications of AI? How do we balance the benefits of VR with the potential for addiction or isolation? These are the questions that will shape the future of computing, and as we grapple with them, we'll continue to push the boundaries of what's possible, exploring new frontiers in the digital landscape. As we look to the future, one thing is certain: the evolution of computers is far from over. From the abacus to AI, the journey of computers has been a fascinating one. We've journeyed through the dawn of computing, the birth of modern computers, the personal computer revolution, and the age of mobile and cloud computing. We've also peered into the intriguing possibilities of the future. In the span of just a few decades, computers have transformed our world, and they will continue to shape our future in ways we can only imagine.